Now that we've defined an atomic number, though, I want to go back to the periodic table and point out two very, very important things. So the first thing I want to tell you is to talk about, well, rows, or which we also know are called periods. So your row or your period indicates your energy level. Energy level. And so now I'm going to tell you something else. If you ever see me write a big E, that is just shorthand notation for energy. So if we just write E level, it means energy level. All right, so what that means is we can look at a row, so the rows are the ones that go across like this, or the periods, and we can indicate an energy level for that specific atom. And so if you have something that's right up here in row 1, you can envision that it has one shell around the nucleus. So hydrogen and helium just have one piece that goes around the nucleus, one energy level. Now if we go down to the second row, lithium, beryllium, boron, any of these, they are in a second row or a second period, so they actually have a minimum of 2 shells. And so their outer electrons are actually just a little bit further out. And so you keep going farther and farther and farther away from your nucleus as you go down this periodic table. So when you get down to francium, all the way down here, we know that these electrons on francium are at an extremely high energy level, and they are very, very, very far away from that center, very far away from that nucleus. And so what we need to start realizing is that as we use this periodic table in terms of rows, we can start identifying relative energy levels. So just in case that wasn't clear, let's make it a little bit, I guess let's just write out a little policy here. So if you have a high row number, okay, so 4, 5, 6, that means you have a high energy level. If you have a low row number, so 1, 2, 3, that means you have a low energy level. This also means that your electrons are very, very close to the nucleus. So whenever we talk about energy level right here, E level, it's just saying where the outer electrons are. It gives you a location. And when we say the word outer, hopefully right away you're going ding, ding, ding. I know a better word for that, valence. So essentially, by looking at the rows of a periodic table, we can determine the energy level of our valence electrons, which is super, super important. So let's just see if we're understanding this. In terms of sodium, potassium, and rubidium, please identify which element has the highest energy level. Go. All right, did we get an answer? Hopefully we did. If not, let's go back to this periodic table and look at our 3 options. So we said sodium, potassium, or rubidium. So the first thing you had to do was find the location on the periodic table. But I asked you to identify the highest energy level. So all you had to do was find the 3 and then figure out which one was in the row furthest to the bottom. So that's definitely rubidium. So rubidium was the answer. Now I'm going to push you. Which one is going to have the lowest energy level? Did you say sodium? If you said sodium, then you are absolutely correct. Sodium has the smallest row number. It's in the smallest period, so it's the 3rd period compared to rubidium, which is in period 5. And so sodium definitely has the smallest energy level, or its valence electrons are located most closely to the nucleus. All right, good. So that was rule number 1 that we needed to talk about. The second thing we need to talk about is actually about the columns or the groups. So what we want to say here is that columns, which we know are better termed as groups, okay, these are going to indicate your number of valence electrons. So we just talked about valence electrons. We know that they are your outermost electrons. They're the ones sitting in your outermost energy level, okay, your furthest shell from your nucleus. But your columns specifically indicate your number of valence electrons. So let's go back to this periodic table. But let's look over here on this section so it's not as messy on this side. So what we can do here is we look at all of these different columns. Every single one of them have a different number of valence electrons. And so what's awesome about this is if you start at the leftmost corner and move forward, so you start over here and move forward, all you have to do is add by 1. So in the very first column, all of these, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium, they all have 1 valence electron. Now, if we move over a column, we move to the second one. Beryllium, magnesium, calcium, strontium, barium, they all have 2 valence electrons. Now, in here is really messy. We have transition metals that gets really fancy. We're going to ignore the D block. We're going to ignore the F block. We're going to go straight over here to the P block, where we have boron. Now, boron, aluminum, gallium, so on and so forth, these all have 3 valence electrons. Then we move up 4, 5, 6, 7, and 8. So your noble gases have a complete full shell, and they have 8 valence electrons every single time. So if this is making sense, you should be able to answer my next question. So here we go. How many valence electrons does bromine have? Go. Did you say 7? Hopefully you said 7. 7 is definitely the correct answer. So what you had to do is go to your periodic table and find bromine. Bromine is right here. And all you had to do is say, okay, which column is it in? So you go 1, 2, 3, 4, 5, 6, and 7. It definitely has 7 valence electrons. So it's really that simple. You just have to find the element on the periodic table and count the number of columns. We are just going to focus on the S and the P block for right now. We will eventually move on to talk about a little bit more complicated things further on the semester, but just for now, you just need to be able to count rows, count columns, make sure you can rank things in terms of energy levels, and rank things in terms of valence electrons. So that's all we have for atomic structure for now. Please, if this doesn't make sense, take a second and go through the book and do some extra problems, because we need to have this very fundamental understanding of chemistry and the chemical elements that we have in order to move forward. Good luck, take care of yourself, and drink water.